Okay, so today we're learning about object-oriented programming in JavaScript. Not really going to be teaching you any like brand new concepts. This is kind of going to be a review of the object-oriented programming that we learned in Python. We're solving the same problem, trying to achieve the same thing, just creating classes that can create multiple instances of some object, like a person or a car or whatever. But we're going to learn about the syntax that JavaScript provides us, the tools that are available to us in JavaScript to solve the same problem. So the first thing to make clear is that in JavaScript, we don't actually have proper OOP classes like in most programming languages. So instead of classes, JavaScript has this thing called prototypes. So similarly to classes, prototypes can be used to define a shared behavior for a group of objects. And when you compare them to classes, they have some unique benefits and they work a little bit differently. But we are not going to be exploring the ways that prototypes are better than or different from classes. What we're going to do is try to use prototypes in JavaScript to just recreate object-oriented programming. So this is kind of the weird, wacky, sad truth of OOP in JavaScript. Nobody actually likes prototypes. Nobody actually embraces them for what they truly are. Everyone who writes JavaScript wishes that they were using like a real object-oriented programming language again. And so we're going to use prototypes in JavaScript to pretend like they are traditional OOP classes. So if all of this looks a little bit strange to you, that's kind of why. We're sort of going to be fitting a round peg into a square hole for the rest of this lecture. Got a hand up, Grant?
Is this something we'll be using regularly, or is this just something that's good to know?
Good question. So most of what I show you in this lecture is not stuff that you will actually have to type out yourself, but part of it is I want you to be aware of what's possible. I want you to be aware of how JavaScript works under the hood, but also when you're debugging your program, you're going to have to know how JavaScript works under the hood because JavaScript doesn't actually have classes. So when you're fixing it, when you're debugging things, prototypes are going to be what you're debugging. So I want you to know how this works. Also, I think a lot of this is pretty common in interview questions. People are like, oh, you say you know JavaScript? Well, like, what's a prototype? And then you'll have to, spout off some nonsense about it that maybe you remember from this lecture. All right. So pretty fundamental to understanding how we will recreate OOP in JavaScript is understanding the this keyword. So remember how we use self in Python when we're defining our methods in our class? Self is just a generic way that our instances can refer to themselves. So if we want to write a method that lets our instance do something with respect to its own data, we can put self in that method definition. So this in JavaScript is pretty similar. It's how we're going to get our instances to refer to themselves, but it has a lot of other uses, a lot of other behavior. It's kind of important to understand. So before we actually get to creating classes and objects, I just want to explain to you the intricacies of how this works in JavaScript. So right off the bat, we'll just keep it simple. I'm just going to console.log this so we can see what we get just in the plainest case. This is not going to be very interesting, but this is where I want to start. Just run it with node. And so it shows us an empty object. So by default, naturally, console log this is going to be an empty object in node. If you do this in client-side JavaScript in the browser, this naturally refers to the window. That's the global object that all other objects are contained inside of. But either way, that's not very useful. So what's more interesting, so more commonly, when you use this inside of a function, this refers to the object that that function is attached to. So I'm going to show you just creating a manual object. So this isn't a class here. I'm just creating a single object manually. It's got a name, and I'm going to give it a function as a property called say hello. Okay, so this is probably the simplest situation in which we can see this doing something useful, meaningful. So here, this appears inside of a function defined with the function keyword. And this function is attached to an object, this Alice object. So the value of this is this object. So therefore, this dot name is the name property on the object that say hello is called from. So note that this only applies to functions defined with the function keyword. Not fat arrow functions like this. So that is honestly the biggest mechanical difference between traditional functions and fat arrow functions, is how they affect the value of this. Traditional functions will reassign the value of this depending on what object that function is attached to, whereas fat arrow functions don't have any effect on the value of this. So that's the biggest difference between these two. So let's just call this function, make sure it actually works. I didn't do something terrible already. Just calling Alice's say hello method. And she says, hello, my name is Alice. Just what I was expecting. Joe, you have a question?
I was wondering if it doesn't work with fat arrow functions, is that because the program internally conflicts, or was that just because structurally it can't handle it?
I mean, I'd say it's because that's the intention of fat arrow functions. Like the reason why they got added to the JavaScript language was because people wanted a way to define functions that didn't reassign the value of this. That's just one of the awkward complexities of JavaScript, is this is always being reassigned and you never know exactly what it is unless you're an expert at all these rules I'm about to teach you. So fat arrow functions are a way to define functions without worrying about that. Does that help?
Okay, thanks.
Cool. All right, so we saw by calling this say hello method off the Alice object, this is able to refer to the Alice object, the object the function is attached to. And so we're able to get this dot name. But now I just told you that only the error or only the function keyword reassigns this. So let's just get a quick example using a fat arrow function just to see the difference. Gonna make a Bob object here. He's gonna get his own say hello function, but this is gonna be with a fat arrow instead. Just copy this line here. He's gonna also say that his name is this.name. Now when we call Bob.say hello, his name is undefined. Because this fat arrow function is not reassigning the value of this, so it still refers to that empty object that we saw before. And that empty object doesn't have a property called name on it, so we got undefined for this.name. Okay, so now I'm going to throw some trickier examples at you. So let me just ask us first, have we all seen set timeout? Can anyone just tell me real quick, what does set timeout do?
It's going to wait that time in milliseconds before it executes.
Right. So if I've got some code that I want to run, but just not right now, I can put it in a timeout, and then this function that I've defined here will get executed after this many milliseconds. So let's just see that real quick, just so you know I'm not lying. So I hit enter, we wait 2 seconds, and then I get my delayed console log. Cool. All right, so based on what I've told you so far about the value of this, what do we expect to see in our console when I run carol.say hello? You can think about this for a few minutes. Remember, when this appears in a function, its value is whatever object that function is a property of.
Is it undefined?
Why do you think that?
Because it's inside the say hello function. Like the set timeout function, or no, the set timeout function doesn't have it. I don't know. Actually, I don't know.
You didn't
Uh,
set a
should be
timer for
defined.
set timeout, but it
yeah.
should still
Sorry,
execute.
I think Porphy had
I
his
think
hand up.
it'll bring up the
Oh,
actual
sorry.
name. I think it'll bring up the actual name. It just take longer because of the set time.
Will it be if the set timeout has a name attribute?
Not quite. Porphy, you got your hand up there?
Yeah, so I'm assuming it's gonna work after 1,000 seconds just because it'll inherit it from the function it's inside of.
Okay. So I'm hearing all your thought process here. It's some good ideas. Let's see what happens. My name is undefined. So we are not able to access the object itself, this Carol object with this. So here's what's going on here. So we've got this appears inside of a function defined with the function keyword. So this function here is going to reassign the value of this to be whatever object this function is attached to. But this function is not actually attached to any object. So this is going to refer to that empty object we saw before, nothing useful. I know it's a little bit tricky because this function is defined inside of another function, which is attached to an object, but that doesn't matter. That's not how JavaScript works. We're just looking at immediately the closest function that defines, or the closest function that uses this, and then what object that function is attached to. It's not attached to any object in this case, so this is not going to have a useful value. Andrew, do you raise your hand?
Yeah, I just got a little confused. So what does this point to specifically, or is it just undefined, or does it point to the say hello function?
This, in this
Yes.
case right here, it's exactly the same as this one up top.
Okay.
So yeah, because this function is itself is not attached to any particular object, this is not going to give us a useful result. It's just going to be the window object if we were doing this in the browser, or since we're doing it in Node, it's just an empty object. Sukhdev?
I just want to make sure I understand. So if the name Carol was after the parentheses after say hello function, then it would actually say, hello, my name is Carol, because the name would be attached to the set timeout function. Is that correct?
No. So this function would need to be a property on some object. Like, see on the Carol object here, we've got the property say hello, colon, and then its value is this function here. So this function isn't just like an anonymous function that I have no way to refer to, that has no name. Like this function is totally anonymous. I pass it into the set timeout and I have no way to access it again after the set timeout runs. But this function is not anonymous. It's a property on this object that I can refer to by carol.sayHello. So because it's a property on an object, this can refer to that object that it's a property of. Whereas this anonymous callback here, yeah, it's not a property of any object. Were there other questions? Brendan?
Yes, could you type that up below it just so I can see the distinction, like to answer the last question? So, because I'm still having a hard time wrapping my head around what it's referring to. So like the same program with Carol, to type it up to where it would pull up Carol.
This just rearranged to make it bring up Carol. Sure, let's see that. So we're gonna get a fourth person here actually. So this one's gonna work more correctly. Okay, so here's a slightly different example. Can everyone spot the difference between Dan and Carol here?
That arrow function.
Right. So how do we think that this is going to change the output from say hello?
So it won't try to assign anything because it's not declared like as the normal function keyword.
So since
Right.
it's not trying to assign it, it's just gonna inherit from say hello.
Right. So just like you were saying, if I'm trying to figure out what the value of this is, I'm going to go to the nearest function that it's inside of that was defined with the function keyword. So I do see that it appears inside of this fat arrow function, but fat arrow functions don't have any effect on the value of this. So I'm going to just ignore that and go to the next function that contains it. And so that gets us up here, a function actually defined with the function keyword. And this function is actually attached to an object. It's the say hello property on the Dan object. So this is actually able to refer to this object, Dan. So this is kind of an example of how I might use a fat arrow function because reassigning the value of this breaks my program. All right, so can we all see the difference between the Carol and Dan examples, where here this inner function is reassigning the value of this in a way that we wouldn't want, whereas in this case, by using a fat arrow function on the inside and then a traditional function on the outside, we're able to control the value of this and make it refer to this whole Dan object. Porfi?
Yeah, so just so for my own curiosity, with the set timeout, does it have to be a function inside of the parentheses, or could you have just put the console log right in there?
Yeah, you have to pass a function to set timeout.
Thank you.
Because yeah, a function is just how you describe work to be done later, basically. Any other questions? Wow.
Just quick question. So if you use fat arrow function, it allows you to put in like another function inside of the original function. Does that mean if you use multiple fat arrow function, you can inherit like more function inside of the set timeout function?
I mean, yeah, if for some reason this is what I needed to do in my program, just have functions inside of functions.
So as long as they are anonymous function, they will still refer back to the original object and grab that information you need.
As long as they're fat arrow functions,
Fat arrow functions.
they will not reassign the value of this.
Okay, thank you.
Yep. Eugene?
Yes, so question about the fat arrow function again. Coming back to the Bob example, is there any way that we can just use the fat arrow function but still have this console log to work?
I'm not sure how I would change this example to make that work.
Okay, so in this type of example, then we have to use the traditional function.
Right. I mean, there might be some other ways that you could use the fat arrow function and then force it to kind of do what you want. I'll show you some of those techniques later, but they're really gross and you would probably just rather use the function keyword.
Okay, thank you.
Any other questions before we move on? Okay, so this next section, I'm going to throw a little curveball at you. So another little trick about figuring out what the value of this is. So I say it's about a function that's attached to an object, but it gets a little more confusing because it does not depend on how the function is defined, but on how it is called. So that's probably a little bit weird to read. So let me just show you what I mean. So before I actually define an object for another person, I'm just going to define the say hello function by itself. So it's the same function, should be referring to this some object that contains this function. But right now it doesn't belong to any object. It's just a freestanding function assigned to a variable name. You can call it by itself, but it's not going to do anything very useful or interesting. Yeah, so it just gives me undefined. Get that out of here. So yeah, it's just undefined if I try to console log this .name by itself. So now I'm going to make a new person object. And then I give Eve a say hello method, but instead of defining the function right here when I'm defining Eve, I'm just passing in a reference to this function. A reference to the function that I'm defining up here.
Basically, that's just because when you put it in the parentheses, that would actually almost like be trying to call the function versus just putting in the name of the function is just referencing it, right?
Well, these are both calls.
Okay.
I mean, here I'm calling the function, we got the parentheses after it. Here I'm calling the exact same function.
Well, I mean, in the actual, in the mat or the object that you defined. So when you say hello, then colon, say hello. That's just because you're just using it as a reference to the
Oh,
function.
yeah. This is just
Okay.
a reference to the function because I didn't want to redefine it. I've just already got it defined here and it's got a variable name. It's not anonymous. So I can just put that variable name in here.
Okay.
And
Thank
yeah,
you.
like you said, I'm not calling it, just passing in a reference.
Perfect.
But yeah, so now we can see some kind of wacky behavior. I have only defined one function here. Everything else here is commented out, whatever. But just in this code here on my screen, there's only one function that's been defined. Here I'm calling it by itself, just as a standalone variable name. Here I've attached that function to an object, and then I'm calling it as a method of that object, but it's still the same function. There's only one function here. But because of the context of how I call it, this gets a different value. Up top, not attached to any object. This is just that empty, useless object we saw before. When I'm calling say hello as a property of Eve, then this can refer to this object because say hello is now a property of an object. And so that's what we saw in my console here. The first log is undefined. The second one, this is able to successfully refer to that object and get us the value of Eve. So that's how the value of this changes naturally when it appears in different functions, when you call it in different ways. In a moment, I'm going to show you how you can force the value of this to be whatever you want it to be, regardless of where it appears in a function or whatever. But before we move on to wilder and wackier stuff, does anyone have any questions about what we've done so far? No? Okay. So why don't we actually take a quick break? It's 10:10, come back at 10:17, and then we're going to talk about call, apply, and bind.
Hey, Raphael, I was wondering, while you were typing the last Eve function, when you were typing the word name, it had a strike through. What was doing that in your system?
That's a good question. The short answer is I don't know, but I know that in some contexts, name is like a keyword or it's special or reserved, or at the very least, my editor thinks it's special. So for whatever reason, my editor was misunderstanding something that I was writing because I hadn't finished the line yet, so it thought it was going to turn into something it wasn't. I'm not really sure. Honestly, modern text
Oh,
editors kind of
okay.
frustrate me with just how much, like pop-ups and automatic like markup and formatting they apply to your code. I'd prefer using dumb, simple text editors generally.
Gotcha. Okay.
I have a quick question
Sure.
on the Eve object. For when you have the say hello, you don't need to have the parentheses on there. There,
Right.
yeah. Okay.
So if I put the parentheses here, that
Mhm.
would mean that when I was defining the Eve object, I'm calling say hello, and then whatever that returns, that's the value of Eve.say hello. But that's not what I want. I just
got
want
you.
her to have access to this function. So let's
I
just
got you.
see that since you said something. I'm going to modify this say hello function. It's going to return 12 because why not? And I say Eve, say hello, but now I'm going to call it. So this is going to break. But we're just going to console.log Eve.
It should be 12.
Say hello is 12.
I got you. I got you now. I see. All right. Thank you.
Cool. Good question. I'm so sorry. Yeah, I forgot to start the recording up when we came back from break. Very sorry about that. Thanks for speaking up.
Oh, no worries.
So here, this is just showing you the difference between call and apply. They're going to behave exactly the same. It's just lets you write your code in a slightly different way. And honestly, in modern JavaScript, apply is even less useful because we have the spread syntax now. I don't know, maybe you've seen this before. So if I want to do math.max in JavaScript, you can pass it a comma separated list of numbers. It tells you the biggest one. So biggest number in that array is 22. Amazing. A lot of people don't like this because you have to pass in your numbers as a comma separated list. It would be better if you could just pass them in as an array. Traditionally, people used to do this using apply. And then you can pass in an array of numbers. But in this case, I don't actually care what the value of this is. So that's why I passed in null. I just wanted to kind of use this trick to pass in an array of arguments to a function that is not supposed to take arrays. So you can do that. Something like that. But in modern JavaScript, this is not really done so much anymore because people just use the spread syntax. So this is probably a cleaner, more preferred way to do this with modern JavaScript. This ... numbers converts our numbers array into a comma separated list of numbers. So it converts it into the format that math.max wants. This is just kind of a historical note that I want to share with you. This is like why applies in the language, I guess, because it's not really obvious what it's used for. I don't think it makes sense in today's context, but knowing a little bit about the history of JavaScript, maybe you can appreciate why this is in the language, why it used to be useful. All right, and so then lastly, bind is a little different from call and apply. So what bind does is it lets you create a brand new function that has the value for this permanently set. So I actually see this one a little bit in some React code. You don't necessarily need to do this, but there are some people that like using bind in their React code to solve certain particular problems. So I guess don't be too surprised if you see this at some point while you're Googling and Stack Overflowing for React help. So let's see. So I've already got this function here, greet, and it uses this in it. So now I'm going to use bind to create a new version of this greet function in which this is permanently set. All right, so I'm hoping that the variable name that I chose here should give you some clues about what this function does. But essentially what I'm doing here with bind is I'm using my greet function and then creating a new function from it in which the value for this is permanently Bob. Just anywhere inside of this greet function where you see the value this, so that's here, this, in this new function, that's just Bob. So this greeting from Bob function, I call it, we're going to pass in Alice, that's the other person, but this is permanently set. I don't have to do any other changes to that. So if we just see that run, sorry, there's a bunch of other console logs here. So greeting from Bob, Alice. So that works how I was expecting. I have forced the value of this to be that one specific object. And so now I don't have to use call or apply or attach this function to an object or whatever. This is referring to exactly what I want it to. Now, you might be wondering, why do I need to know this? When am I ever going to use this stuff? And if you're lucky, you won't. But the point that I want to impress upon you is that this in JavaScript is a fickle value. It can refer to different things. It can, be reassigned from one call to the next. It can be reassigned between when you define it and when it gets called. And oftentimes when you're using frameworks such as React, you'll have to write functions that use this keyword. And so what I want to impress upon you is that you have no way of knowing what this refers to just by the way you've written the function. You need to read the documentation for your framework and find out, like, how is this being used? What is the expectation of how this function is going to work in the rest of the framework? This is going to happen a lot. Is you're going to define these functions that you never call yourself. You just give them to the framework, and then the framework calls these functions for you as appropriately. But that means that you're going to have to read the documentation to understand what this is supposed to refer to and how you're supposed to use it. Because under the hood, the framework might be reassigning this using some of these techniques that I've shown you today. So don't reason too hard about what this is supposed to be in those cases, because it could be anything. Just read the documentation and see how you're supposed to use the framework. So it's about time for a break. Does anybody have any questions before we take a 10-minute break?
I have a question.
Yep.
Where is Bob defined on the file? Oh, up there. Okay.
Oh, this might be getting a little confusing. So that was the Robert object. Bob is actually up here. I probably should have just used an entirely different name. So yeah, it's the same name property, but at least now I'm not referring to something at the top of the file. Any other questions?
Is there a reason why you're using a separate terminal?
I like it. It's comfortable for me. I've been using the regular plain terminal at the command line for like 10 years. And at this point, it's customized to be exactly the way I like it. Whereas text editors come and go, I guess. You know, I've been using VS Code for the past couple of years and it's great. But before that, I was using another editor for a few years and another editor for a few years before that. And I'm just kind of tired of the interface changing all the time. Whereas the command line always works the way I want it to. I just feels more powerful and convenient. I don't know. The exception is if I'm developing on Windows. I think the native Windows terminal is just terrible. Like it was built by people without eyes and the color scheme is just terrible. So in that case, I would definitely prefer to use the VS Code terminal. But generally speaking, this is all I need. Any other questions?
Yeah, Ralph, it was less of a question, more of just a comment. But the reason I think she was asking that is when you're trying to teach us as learners, when we can see the code and the output at the same time, it makes it a little bit easier to grasp the concepts. When you're just tabbing back and forth, it's kind of disorienting. I know it's more effective to code it that way, but when you're trying to learn, it's not so much.
Okay, it's distracting, you're saying, just flipping back and forth between tabs.
That and just being able to compare one for one what the code says versus what it does.
Sure. Guess if you're into that. Cool. Anything other questions?
I have a basic question, Rafael.
For sure.
So is that true when you're trying to pass in an object to become the self.value? It has to be in a form of object.
I want to say yes. JavaScript is a little bit weird in that at some level, everything is an object. So you can probably pass some strange things in there and get more successful results than you might expect. But in general, let's just say that this is supposed to be an object.
And I saw in the apply method, you used an array format.
Right.
Will it break the code if you put like multiple names in it? Like say the Alice in the array in the apply method. Right. Okay.
What are you asking if I just put like
multiple names? Will that break the code, or you have to specify which value you're trying to use?
This won't break it, but it also won't do anything productive. So where is it? If we look at the greet function, this greet function only takes in one argument. And so what this is doing effectively is just passing in two arguments to a function that was defined as only taking one. Okay. So in Python, I think that would throw an error because you're clearly using the function the wrong way. You know, you pass in two, it only takes one. You should figure out what you're doing. In JavaScript, though, if you pass in too many arguments, JavaScript will happily ignore all the extra arguments. So Alice gets into the function as other person. Jeff is passed in with no particular name and doesn't really do anything interesting.
Okay.
Brandon?
Yeah, so if that greet function is defined as an arrow function, like does that affect the way that call, apply, or bind works?
I'm expecting it won't.
Okay.
It does. I couldn't get the call. I couldn't get call to work when I defined it as a arrow function.
Let's see. So I've got greet.call. All right, we're doing this down here now. Now, if I make this an arrow function, seems so. So yeah, I guess if you want to use call, apply, or bind, the original function should be a traditional function. Otherwise, you can't reassign it. Interesting. I mean, for sure, the last time I was using call, apply, and bind extensively was before arrow functions were introduced in JavaScript. So yeah, I guess I've never tested that. Do we have any other questions before we take a break? Going once, going twice. Okay, so it's 10:42. Let's come back at 10:50. And then I'm going to talk about the new keyword in JavaScript. Hello, welcome back, folks. Hope you enjoyed your break. So in this next section now, we're going to actually define a class in JavaScript. It's where we're getting closer to the parts of where you're learning things you'll actually do in your daily JavaScript coding. So now what we want to do is create a class. That is, I want to create some like constructor that is able to create many other objects that have some standardized set of properties and some behavior that they share. So that's kind of my goal here. That's what I'm trying to recreate, because we don't actually have classes in OOP. I'm just trying to recreate that functionality. Now in JavaScript, we don't actually have a class keyword. Well, we do, but it's not like a real class. We don't really have classes in JavaScript. What we're going to use for implementing our class is a function, because that's really the best thing we have in JavaScript are functions. So we're going to use functions for everything. But if you want to use a function as an OOP constructor, we're going to call it a little bit differently by adding a new keyword. Has anyone seen the new keyword in JavaScript yet?
Seen it before, just had no idea what it was.
Okay, well, now you're going to learn all about it. So let me just show you a function here that one might use as a constructor. All right, so I'm not done here yet. Obviously, this is an empty function. But already what you see here should look like valid code. You know, I'm calling this function, assigning it to a variable. The function doesn't do anything, it doesn't return anything, but this is at least not going to throw an error. So this is how you call a traditional function. If I want this to be used as a constructor function, I'm going to add this new keyword. So this makes it behave as a constructor function. We're changing the way the function executes. So more specifically, what that actually does is it makes two things happen automatically when we call the function. And it's a little bit something like this. At the start, creates an empty object for this. So it doesn't matter what this was beforehand. If you call a function with new, this is a brand new empty object at the top of that function. And then at the bottom of the function, this happens automatically, return this. When you call a constructor function using new, you don't have to explicitly return anything. This is automatically returned from that function. So then the rest of what we have to do in this function is just add properties to this so that it's actually useful. So I'm going to add a name property on our person object, and that's just going to be whatever is passed into the constructor function. So we're calling person with Alice. That's going to be their name. We assign it to this dot name, and then the new this object gets returned. So if I want to just console.log Alice, do we have any other logs here? Let's get rid of these. Right, so we got Felicia instead. I'm running out of names here. Okay, so here's what we get when console log Felicia. It's telling us very helpfully that this is a person object, came out of a person constructor, this thing over here. But this is the actual contents of the object. It just has a name property with the value Felicia. So that's just what we're assigning right over here. If I want, I can make this a little more sophisticated, add another property. Say she takes age. I'm gonna add that in when I call the function. And similarly, I'll just attach it to this. So now just whatever I attach to this, it is automatically returned. I don't have to actually write a return statement. I don't actually have to declare this. Those things happen automatically when you use the new keyword. Andrew, do you have a question?
Just a comment. It's interesting how in Python, when you like print the when you print the object you're doing, it just points to the object, but this point in JavaScript, it points directly to the dictionary being created.
In part, that's because just data types in JavaScript are a lot simpler, just the way that like kind of everything is an object. So I think it's a lot easier for JavaScript to guess what a useful way to print an object would be. It doesn't always guess correctly, but usually it does. Whereas Python, I think, is more hesitant to just like print out everything it knows about an object because it might be a lot of weird stuff you weren't expecting. And so that's why Python has that dunder string method. So you can specify how to print an object because Python doesn't want to assume. I do wish that Python had a more useful default behavior of showing you some of the properties or something, but that's how it is. Any other? Jake, what's up?
So you only ever use new in like a function call. You wouldn't use it to create a variable or anything like that. use it in a function definition or anything, right?
So you do not use new in the function definition. You use it in the function call. I think that's what you said. But also I am using this to assign to a variable. You know, I'm calling person with the new keyword, and that returns a new person object. So generally I want to store that somewhere. So I'm assigning it to this variable. Porphy?
Yeah, thank you. So is the function when you did const person equals function and then you put in the parameters that they could bring in, do you have to have the parameters in there? Like, is that like the init in Python, where you have to have the parameters there so that they can be brought in, or can you just put in random parameters inside of the person constructor, I guess?
That was a great comparison. This constructor function is the same as the Python init method. So any of that like initial setup for your objects that you have to do, like where you're assigning the input arguments to the object and any other setup that you need to do, just like you would do in init, you do in this constructor function here. I saw some other hands.
Jake's question earlier made me think of something. Could you just put new somewhere in the constant, like in front of like person, and then when you call it, it'll automatically create that new instance instead of having to put it when you like are creating like Felicia down there?
Are you asking if I can do like this or something?
Something
Nah,
like that.
Sorry. Yeah, this is how it works. You've got to do it when you call the function. And honestly, what you're saying sounds like a good idea to me, because like I know at the time that I'm writing this function, this is only going to be used as a constructor, just because of the way I'm assigning to this, and it doesn't actually return anything. The only way this function makes sense is as a constructor function. I know I'm never going to call it without new. And so it is a little bit obnoxious that I can't define that up front at the definition, and I have to include it every time I call it. But that's JavaScript for you. I think we saw another hand up.
You answered my question already. So you'd never call person the function without the new keyword, right? So
correct. This person function, the way I've written it, will be completely useless. And I would say it's a mistake if it were ever called without the new keyword. Any other questions?
So there'd be no reason like to create I guess it's just the way the language is written. I think of classes, everything collected nicely under like the keyword, the class name. In here, there'd be no way to group a bunch of functions like that are written with that syntax. There'd be no way to collect all those together nicely in one little section together that you would say, this is my person class or whatever like that, right? It's just a bunch of loose non-bind like functions that are not kind of stuck together. They're just kind of floating around out there in the code somewhere.
Well, so far we only have this one function. So far, my entire class is contained inside of here. And then this is just using the class, this is calling it. But we will see in a moment, actually, that what you're saying is true, that our class is going to be kind of floating around in a few different places and not as neatly contained as we might like.
Okay, because yeah, what I'm seeing here is you're using one function as like the class constructor, but it doesn't get, it only gives you access to variables. It doesn't create like special function, like methods to use. So that's what I was wondering, if there's a way to collect those under some larger section called person or something. But yeah, I guess you'll get to that eventually.
That's actually the next thing that I'm going to get to. So So let's imagine instead of just one person object, I have like 1,000 person objects. You know, I could do something like okay, something like that. Like maybe I'm not even assigning them all the variables. I've just got an array of just like 1,000 person people. So just let's imagine we've got a lot of these folks. Each of them might have unique data for their name and age or whatever. Let's say I want to give them some behavior, some functionality. I could do something like this. So technically this does work. I can define a function inside of the constructor, and then that'll be applied to all of my objects. But this is not actually the correct way that you're supposed to do it. The problem here is that if I create 1,000 person objects, each one of them is going to get a copy of this say hello function, and that's considered wasteful. I should be able to define this function just once and have all of my person objects access it. So I'm just going to delete this so you don't accidentally remember that. And this is where prototypes come into play. So every function in JavaScript has a prototype. Has a prototype property, which is itself another object. And this defines shared behavior for all instances that you construct from that constructor. All right, so the way we do that, so like I said, every function in JavaScript has a prototype property. So I'm going to access this, and now I'm just going to start adding methods to the prototype. So now I can Felicia.sayHello. And that works the way I was expecting. Hello, my name is Felicia. So note when we define our person, there are no methods defined here in the constructor function. All we have is this say hello method that's attached to the person prototype. And in fact, I added this here after I created the Felicia object. So this is another bit of just JavaScript wackiness, but I have defined my class. I create an instance of the class, and then after creating the instance, I add this say hello function to the prototype. But then even though I added the function after creating the instance, I can still call that method because this lookup happens dynamically. When I try to call Felicia.sayHello, first JavaScript is going to check if Felicia has a say hello method. The answer is no. And then it's going to check Felicia's constructor's prototype and see if the constructor's prototype has the method named say hello. And in this case, it does. So that's the one that we call. Porphy, question?
Yeah, thanks. If you do console.log for person right now, will it show that method in the, will that in the object?
I was saying like so. Oh, wait. So that just tells you that it's a function. Let's see if we, is that any different? Nope. So this is one of those examples where JavaScript does not give you as useful of information as you like, because this is how JavaScript prints out functions usually, but in this case, the function is also an object that has properties on it, and I want to see, but JavaScript is printing it like a function, not an object. Or at least we can look at person.prototype. I guess that's not as exciting because you saw me assign directly to it. Let's take a look at constructor. Okay, so Felicia.constructor is this function. Felicia.constructor.prototype is that prototype object with the say hello method on it. So this is how every individual function or every individual object in JavaScript has a connection to its constructor, the function that created it. And then that constructor has a reference to its prototype. So this is how when you call a method on object, but that actual object itself does not have that method, maybe belongs to like a parent up in the prototype chain. This is kind of how JavaScript figures that out. It can go from constructor to prototype. And that prototype might have its own constructor with its own prototype, so on.
Is this classified as a prototypal inheritance? Is that what it is?
Yes, technically you would say JavaScript has prototypal inheritance. Not prototypical inheritance, that's a different word. Prototypal inheritance is how we describe this. But honestly, if you just talk about OOP in JavaScript, I don't think anyone's going to correct you about that. Because like really the whole point of what we're doing is to pretend like we have OOP using our prototypal tools. So if you can keep pretending for the whole conversation, that's fine. All right, so does everybody have a general sense of how we're doing this here? Got the constructor function, attaches properties to this. The prototype has the shared behavior. So we've kind of got this split between data and functions, data and methods.
So I guess the way to keep that from being as confusing, you would just, you would have this class, and it's not a class, but you would have this new function or person. You just, the way, I guess the best way to organize it, you just keep it all in the same file.
Yeah.
So like say, how would you call that person, that prototype dot say hello? Say if I created a new instance of that, you just do, okay, just say hello. Okay.
Right. Yeah, just Felicia.say hello. But yeah, practically speaking, I would probably have one file that has the constructor function and any methods that I add to the prototype all in that one file. Because together, I think of those things as being the class. I would rather that they were all in one set of curly braces, but at least I can put them all in the same file. And so that's a decent enough form of organization. Okay, so.
Sorry, Raphael,
Kat?
can I ask you a quick question?
Please.
This might be jumping the gun, but I know that there is the keyword class in JavaScript.
Mm-hmm.
Are you going to talk about that today, or is that like beyond today's scope?
That is the very next thing I'm going to talk about, and is the last thing in today's lecture. Good question though. Glad you're all thinking ahead. But anyways, so I've made you suffer enough through traditional old school JavaScript. I'm now going to show you kind of a preferred, cleaner, more modern way that people set up their classes, and that is with an actual class keyword. This is a relatively new addition in JavaScript. So I am going to show you a
That was
class.
true government fashion there, Raphael.
Excuse me?
I was saying that was in true government fashion there. In JavaScript, we don't use classes. Oh, by the way, there's this new keyword called class.
I'm not trying to confuse you. I swear it's just JavaScript. So my point here is that I'm about to show you a keyword called class, but we still don't have classes in JavaScript. What this keyword does is it automatically sets up your prototypes for you. So it's going to give you the same results. It just lets you write cleaner code. So the way I would create that person class using the new class syntax. Actually, before I do that, we're going to comment this out. So that's going to conflict since I have multiple things named person at this point. All right, so class person. So everything related to this class is inside this constructor function. Or I'm sorry, is inside these curly braces inside this class definition. But then I separately define the constructor function. It is helpfully named for what it does. It takes one argument. So this is even more similar to init in Python because we got the class definition outside. Inside of it, there's constructor other than init. I actually prefer the name constructor because it doesn't have 4 underscores in it, but whatever. And then if we want to add methods, we just put them right here inside of our class definition. Give it a say hello method. So that's how we define a class using the new class keyword. But the way that we instantiate objects is exactly the same. So here, our new Mallory object works just the same as the ones that we got out of all of the other constructor functions. If I want to dig a little deeper, again, .log Mallory.constructor. See what that is. It's a person class. So the console log is a little bit more useful. It tells me it's a person instead of just function. If I look at prototype, not exactly what I was expecting here. I'm not able to get the logs to show you exactly what I wanted to show you. Might have to dig into this a little bit deeper. The point that I'm trying to make, though, which is not very easy to see right now, is that under the hood, this is not different from what we were doing earlier in this lecture. We still have prototypes and constructors in JavaScript. So you still need to know how all that stuff works under the hood, because when your classes break, you'll have to debug prototypes. I wish I could show you that better here. I'll have to get back to you on that. But anyways, for your actual day-to-day programming, I strongly suspect that this is how you will prefer to write your code. This is much more common in modern JavaScript. I want you to not be surprised if you see it written the other way, because it was not too long ago that that was the only way we could do OOP in JavaScript. But certainly for projects that you start today, this is going to be, I think, much more convenient for you. So that's all I have to say about object-oriented programming in JavaScript. Just wanted you to see a different set of syntax for learning the same concepts you already learned yesterday. We can take some questions and then take a break, and then we'll use the time remaining this morning to review the contact list exercise. Does anybody have any questions before we break? Andrew?
Yeah, just trying to wrap my head around the differences between Python and this. So when you define your say hello function in there, if say hello had a like a variable it took in, you would only need to call it with one variable in JavaScript, but in Python, you have to call it with two, right? You have to call it with self and then the variable, but in JavaScript, you would only need the one.
That's right. So I guess that's another difference between Python and JavaScript in how we define our classes. In JavaScript, it's just kind of assumed that this is always available to you. And so I don't have to specify that this is passed into this function. It's just any function can always use this to access the objects it's attached to. And since these methods, when we call them, they appear on Mallory or whoever, this is going to work out properly, refer to the object itself, and access that name property. So in Python, that's, in my opinion, kind of one of the uglier parts of Python, is that when you define your instance methods, you have to specify that self gets passed in, even though when you call the function, you don't pass in self, it just gets in there automatically. So there's that slight mismatch, which is maybe a little disorienting when you first learn Python. You don't have to deal with that in JavaScript. It's a good observation. Any other questions?
I just have a comment. If you put a breakpoint on that console.log, you might be able to see the kind of the structure of all the prototypes from there, since console.log is not working really well right now.
Yeah, I'm not sure if a breakpoint is what I need. I have a hunch that there might just be a difference in how the browser prints these out versus how Node prints these out. In the past, I would have done this demo from my browser. I'm not sure if that actually matters. Maybe over the break, I'll test that out real quick and see if I can get anything different to print out. Do we have any other questions? No? Okay. So let's take a 10-minute break. Let's have you all come back at 11:30, and then I'm going to show you one solution for the contact list challenge. All right, welcome back, everybody. So before we dive into the exercise review, I just want to show you real quick what I was talking about before we left for the break. So I tried logging these values in Node.js running here at the terminal, and it wasn't exactly giving me what I was expecting to show you. So I tried running this instead in the browser, and it looks like when you run the same JavaScript code in the browser, browser.js represents these values a little bit differently, and it'll actually show you what I'm trying to show you. So we're logging three things here. First, just the person class itself, then Mallory's constructor, and then Mallory's constructor's prototype. So I've got this loaded up in the browser and refresh the page. And so we can see this is our person class printing out. This is Mallory's constructor. You'll note it's the exact same thing that just printed twice, because Mallory's constructor function is the person class, because we don't really have classes, we have constructor functions. And then when I print out Mallory.constructor.prototype, it gives us this object, which has two functions on it, being the constructor function and say hello. So even though I've set this up using the class keyword, I still have prototypes underneath it all and constructor functions. So if my code breaks, I need to inspect it and see what's actually going on. These are the things I'm inspecting. So it's important to some extent that you know what JavaScript is made of. All right, so I'm going to switch gears now and code out the contact list challenge for y'all. Feel free to ask any questions about what I just showed you while I'm moving around making some files.
I got a question, Raphael.
Yep.
So you said in JavaScript, we're just kind of like trying to recreate Python classes or object-oriented programming.
Right.
And we don't really like access the full potential of prototyping.
Right.
So what would be like an example of what else prototyping could do?
That's a great question. I honestly have no idea. Because literally nobody cares. Like nobody appreciates prototypes for what they are. Like even if they were great and you learned all about them, you'd be the only one. So like you go to any other company and you show them like, oh, look, we can like avoid reusing code by using prototypes. And they're gonna be like, no, we're not doing that. Let's just use classes like everyone else does. I think at one point I like studied this, but it would have been like 7 years ago or something. There is a similar but different way that you can get a bunch of objects to share methods from some like ancestor object. But it's not like better than object-oriented programming anyway. It's just slightly different. And I guess people don't want to learn OOP twice, more or less.
Thank you.
Yep. Any other questions? No? Okay. All right, so I got my main.py file. All right, so let me just try to keep myself straight. What are my goals here? What am I trying to do? You define a class for a contact list. Needs a name and a list of contacts. It's going to be a list of dictionaries. That's a pretty common way to store data about multiple people, multiple things. List of dictionaries, very common data structure. Let's see. Contact list needs to remain sorted to be able to add and remove contacts. And then lastly, you need to be able to generate a new contact list that contains shared contacts between two other contact lists. All right, so just dive right into it. I'm defining a class in Python, so I'll just use the class keyword. Need an init method to get things started. We have to specify self as the first argument, and then the actual interesting arguments are the name and then the list of contacts. All right. So I've like kind of checked off first couple of requirements. We can add a name and contacts to our contact list, but this needs to be sorted. So in this constructor function, I'm going to sort the contacts after we've assigned them. Okay, so I need to specify to Python how I'm going to sort this. So we're going to give it a key. Now, Python sorting works a little bit differently than JavaScript. In this case, because I'm just sorting a bunch of dictionaries by one property of those dictionaries, I can actually kind of use one of Python's little shorthand helper methods. So I'm not going to have to define like the full comparison function that you saw the other day for sorting, where I compare two objects at a time and return positive, negative, or 0. This is going to be a little bit simpler. I just need to tell Python which property on the object or which property on the dictionary we're using to sort it. So you can pass in a function here. I'm just going to define it up top here. So very simple function. If you pass in an item, it'll return the name property of that item. I'm going to pass it in over here as our key for the sort. So this is just specifying to Python how we want to sort our contacts array. It's going to use this function getName, which is just going to return the name property off the item. And that tells Python that the item at name is the key we want to use for sorting the dictionary, sorting the list. Lyman?
Yeah, I was curious why you define the getName getter function outside of the class. Is there any pros or cons to how you did it or why you did it that way?
Yeah, there are some pros and cons. I don't think it matters too much. Some people might think it's cleaner to have this be part of the class. Something like that. And I could say key equals, I think self.getName. That should work fine also. In my mind though, like this function is so generic. Like this doesn't really have anything specific to do with contacts. This is just sorting anything that has a name property. I might use this function. So maybe in a larger program, I might have a bunch of different classes or just a bunch of different use cases where I need to sort things. And so I might be reusing this function. So I would probably define it in a separate file and then import it here. That's a good question. That's definitely the kind of thing that you'll need to think about as an engineer. So, how much does code get reused? Where does it get reused? What's the best place to put this code so that it's easily accessible by all the other places where we need to use it? These are kinds of organizational questions that you need to ask yourself. All right, so that should be sorting our contacts. So before I do anything else crazy, let's just try running this code, see if I can actually make a contact list. First, I'm going to make a few contacts that we can add to a contact list. So I'm just going to make some dictionaries for people here. It's not going to be super interesting. And then lastly, Eve. All right, so we've got 5 potential people that can be in a contact list. So I'm going to make a new contact list for my friends, call it friends list, invoke the contact list, call this list my friends. And this is going to consist of Alice, Bob, Carol, Dan. So I said contact list takes a list of dictionaries. Each of these people are themselves a dictionary. And I just passed in a list that I created right here with some specific people added in. Let's just print friends list, see what that looks like. Oh, gotta change that. So it gives me the not so helpful, it's an object description. So let's print out friends list.name and friends list.contacts. So the name is my friends, and these are all the contacts with their name and number. Let's just make this more interesting. I'm going to put these people in out of order. All right, so when I call this, I'm adding them in not alphabetical order. And yet, once I log it after I create this contact list, it looks like all the people are here in alphabetical order by first name. So this sort function seems to be working the way I want it to. So next thing I'll need to do, now that I'm able to sort my contact list, I need to be able to add and remove contacts. So add a method, add contact. Again, it has to take self and the new contact we're adding. So this is going to be pretty simple. Assuming the contact is a dictionary, just like one of these folks, we just add it or append it to the list. But then we also have to make sure that our list remains sorted, because we just added a random person onto the end of it. We don't know if they're in the right order. So I'll just run this sort function again. Just make sure I can do that. I'm going to say friends list dot add contact Eve. And then we'll print these again. Okay, so it looks like that worked. I can see in the second call to my function, we've added this Eve object. And it's sorted properly in alphabetical order. So that's all great. I'm sorry I'm going kind of fast just in the interest of time because I don't want this to cut into lunch, but do feel free to ask questions, interrupt me whenever. Remove contact. It's going to be similar. Instead of taking a contact object though, it's just going to be by name. So you just pass in their name as a string, and then I'm going to loop through my contact list and then remove any contact I find with that name. So if you have 11 Johns in your phone book, I'm sorry, this method will remove all of them at once. So we're going to loop through all the contacts, check if its name is the name that we're looking for. And if it is, we remove it.
Contact name has to be self-contact's name, right?
Well, this is the loop variable. And oh, I just need a colon there because I know how to write Python. So yeah, self.contacts, this is the contacts list from the object itself. But then contact is just a loop variable that we're creating right here for each individual contact.
The reason why I was asking isn't if contact name, isn't that checking for the variable of the name inside of self contacts?
Right, but it's checking each individual contact one at a time. And then it's checking that against the name that's passed in. So if I do friends list dot remove contact Alice, spelled her name lowercase, yeah. So this is gonna loop through self.contacts, Alice, Bob, Dan, Carol, and Eve. And then if the name is equal to this name, so that's, Alice.name. If that's equal, then we remove it. But we've got to look at every one of our contacts to check. You seem puzzled.
Yeah, because so right now I'm just a little confused. So right now it's like for every single key. Oh, never mind. I see it. I got it.
Cool.
If you print the contact, it might make it a little more clear.
Yeah, no, I got it now. So it's like, because I was thinking in my head, like for key and value and the contact, you're actually going inside of the key value to look at the value pair.
So these are all the contacts in that loop. Just one at a time printing out. All right, so let me just confirm that my remove contact method is working. So the second to last call, we've got all the people in this phone book, Alice, Bob, Carol, Dan, Eve. And then the next call, we're missing Alice because we removed her, just Bob, Carol, Dan, and Eve. So that looks correct. That's roughly what I was expecting it to be. So now for the trickiest one, we need to find shared contacts. Again, always got to pass in self. And then we're passing in an other contact list. So we're defining a method for our contact list that takes in other contact lists. This is really like one of the most powerful parts of object-oriented programming is in how you can define how your objects interact with other objects in your code. And it's more interesting when these are different classes. You can define how one class interacts with all the different classes in your code. If you have a lot of different types of things. So first of all, I'm just going to make an empty contact list. There's a few ways I could do this, but I'm going to make an empty contact list and then add contacts to it as I find matches, find shared contacts. So for the name, that's just going to be a combination of the two names of the parent contact lists of the original and the other contact list that are used to create this shared contacts. So we'll just say all right, and then I just pass in an empty array for the actual contacts because now we're going to loop through both contact lists and see if we can find any people that exist in both of them. So I'm going to do a little nested loop here. Wait. Sorry, this is the single trickiest line in this whole program. Contact name. Okay, so we're looping through both contact lists, comparing everyone to everyone. And if we find someone who has both the same name and the same number, then we'll assume that it's the same contact. We can't just compare the objects with the equal sign, because that's going to give us misleading results, because all objects are unique, even if they have the same properties on them. So here I'm actually checking their properties, make sure they have the same data. And then if that is the case, they have the same data. I'll use the add contact method that I defined and add the contact. And then at the end of this all, we return shared contacts.
You forgot the colon at the end of the if statement.
I did indeed. All of the Zoom pop-ups are taking up space on the right side of my screen, so I can't always see stuff in the margins like that. All right, so let's test that out, make sure that works. So I've got my friends list who has Bob, Dan, Carol, because we remove Alice here. Let's create another list. All right, so my work friends is Alice, Bob, Dan, and Eve. Whereas my friends list is Bob, Dan, and Carol, because we remove Alice on line 64. And then let's try to find some shared contacts. Question, Jake?
Yeah, I was just wondering if that shared contacts list is that going to be like a deep copy the way you created that? Like if you were to go and delete a contact from the friends list and that shared contact consisted of that name as well, would it delete in the shared context, or does it create like a copy of it that's just going to be floating around out there?
You should be able to add and remove items from the different contact lists without it affecting each other. I think in this specific case, though, if I just went up to these objects and then just said, Eve's name equals not Eve, because these same exact objects got passed around, it's the same Eve object that gets passed into work friends, or let's say it's the same Bob object that goes into both friends list and work friends. Like technically it's the same object. So if I modified a property on it, it would change it for both of them. Although I can remove Bob from one of the lists and it doesn't remove him from the other list. More practically though, this wouldn't matter because you wouldn't normally be reinserting the same objects into multiple lists. Kind of did that just as a quick shortcut here for educational purposes. But these would more likely be entirely separate objects to begin with that you're putting into entirely separate lists. So you wouldn't normally need to worry that modifying one of these would change another. Does that help?
Well, I was thinking I mean, if we were going to use this app in real life, I would, if you remove somebody from an individual list, then you'd want them removed from the shared contacts, right? Because otherwise you'd have to go through every single list you have on file, and then you'd have to, it's, you know, the whole idea of redundant data. So that's why I was wondering if I know in other languages, you know, if you use like, what is it, a copy constructor or something, where you go and you copy not just the string and stuff, but its actual location in memory to make sure that when you change an object or whatever, like you said, if you change those names up top, the actual entries, it would change them, but not in the actual list. So I was wondering, do you have to go use like a self keyword and stuff and copy them that way, or whatever? I know that's probably maybe a little more advanced than where we're at right now, but yeah, so I was thinking for this kind of app though, you would want it to remove it. Yeah, because if you no longer work with Bob, and then your shared contacts, your shared work / friends, Bob's still in there, then it could be confusing in that.
Yeah, so that's an interesting point, that this shared contacts is not dynamic. It doesn't update in real time when the other contact list that it depends on changes. And here, that's by design. That's how I wrote my code to work. It's possible that for your applications, that kind of workflow won't work for you. And so instead of actually assigning shared contacts to a variable, it might be more useful to just recalculate this every time you need the shared contacts. So just call find shared contacts from work, friends, passing, and friends list every time you want to know who those mutual contacts are. Just so you always have the most up-to-date values. And in some frameworks, you'll find that you can set up like computed properties where it basically does that for you automatically. It's just constantly reevaluating some expression or some logic to make sure that some particular piece of data is always the up-to-date version of some calculation. So it's definitely a useful thought to be having right now.
I was thinking about the function that you created to get the data. Could you also use like a Lambda function inside of the sorted method to do the same thing? I'm just thinking of like different refactoring ideas. If I were to,
Yeah,
right.
So I would say actually using a Lambda function would be more conventional in this case. And in fact, that's probably why Lambda functions exist in Python, is because if this function was only going to be used once, it would totally make sense to just define it right here with a Lambda function, because that's just the cleanest, most concise way to do it. It's just one line of code. In this particular case, because I'm using this function at least twice, I thought it'd be nice to define it outside and then just refer to it. Now, I still could have used a Lambda function to define it here, but at that point, it doesn't really add as much value. Like the great thing about Lambdas is just that they're one line expressions. You can sneak them right in there. I also just didn't want to write a Lambda function today. I thought it might be easier for you all to read and digest if I used a traditional Python function. So I assume you're more accustomed to those. But certainly in like professional code, I think it's more common to use Lambda functions for these key functions.
Okay.
John?
So when you're defining the get name outside of the class, when we're doing this real world, we would do a private function in the class for Python, or to kind of keep everything encapsulated, or is it just for demo purposes today that you did it outside of it?
It depends on if you expect to use this function outside of the class. If this function is only going to be used for sorting things inside of contact list, sure, I could define this as a private function inside of here. That would make sense. I'm kind of imagining that this function is so generic, I might use it for other classes and other sorting situations as well. So I'm defining it outside of the class. Like it might be defined in another file entirely and then imported into here.
Can you show the find shared contacts one again?
Yeah. So, or did you mean like see the code, or you want to watch it
Yeah,
running?
like the function or the method. Yeah, I just want to see how you did it again.
So that's the definition there. And here's the output. So it automatically concatenates the names of the two parent contact lists with a slash, and then pushes in all the contacts that exist in both lists. Here it's just Bob and Dan. Any other questions?
Yeah, I have a question about the get name function.
Yep.
Can you explain a little more about how does the item argument pass into the sort function? Because when you put key equals to get name, there isn't any arguments in it. So I'm not sure how that works in this particular line.
Yeah, so that's just how the sort function works. It's not obvious just from reading the code, but I know this from reading the official Python documentation that this is how sort works. It takes in a function, sort will call that function for you, and that function needs to return some property of the object that is sortable. Because the actual thing that we're calling sort on is just a list of dictionaries. Python doesn't automatically know how to sort a dictionary. So the job of this function is to return some property that is sortable. So in this case, the name. Yeah, I totally understand if this looks kind of weird the first time you've seen it. So I would encourage you to read the Python documentation about sorting and see some examples of how this is used, and it'll explain what's expected of you. Any last questions before we break for lunch?
So sort has to take in a function. You couldn't just put name in there. It's strictly a function.
Correct.
Okay, interesting.
I would like to do this. I think that would make sense. I think Python could have totally be written to work this way, because all the function does is just get a specific property off the object. It's not like any arbitrary logic you want. It's just which property are we sorting by. So this specifies the same information. I don't know why it couldn't have been like this. But
Okay,
that's Python.
perfect. Well, thank you for the explanation.
You're welcome. Any other questions? No? Okay, great. So thank you all for attending, listening, asking questions. Hope this was useful and informative and not too terribly tedious for you. Let's take a full lunch, come back at 1:10, 1:15, whatever you want. I don't know. There's nothing in this afternoon, but you've got exercises to work on. App users 2, stock picker, and pig Latin. I'll be around on Slack. Feel free to ask questions if you have any questions. I think I saw a last minute hand go up.
Yeah, I raised my hand, but then I'm just curious how, like, I guess in JavaScript, we didn't go, or I don't know if we went over how to like add a parameter to the prototype. I think that's what it's called. But I'm sure that will come up.
I mean, like add new methods to it to like create more functionality.
Yeah, I guess so.
So that's just, oops, what did I just do? Right here. We have our person class. And if we want to define a new thing that a person can do, we just attach that method to the person prototype. If I wanted to define another thing a person can do, I could just define another method. something like that. Just attach more methods onto the person prototype. It looks a little weird because it's not all contained in one block, but that's JavaScript.
Yeah, I think I get that. I guess what I was wondering is if we had to put in like an extra parameter into the function, if that makes sense.
So, I mean, just like a regular function, if we want to pass in some parameters, I can name it in the argument list here. Just use it over here. Hello, other person. My name is this dot name. And now when we call say hello with an other person passed in, it'll log the person's name and also the name of this, whoever it's called off of.
And that would work the same if it was in like the class.
Yep.
Okay.
You just add arguments right here, and then they could be used when we call the method.
Okay, cool. Thank you.
You're welcome. Any more last minute questions? Going once, going twice. All right, thank you, everybody. So let's break for lunch now. And I'll see you all at 5 for a stand down.